This next vodcast discusses section 16.5, strong acids and also strong bases. And there are 7 strong acids that you have to memorize. These will not be given to you in any way, shape, or form on the AP exam. You'll have to know when you see HClO3 or HClO4, that's a strong acid. So these 7 strong acids are by definition 100% ionized in water. They exist totally as ions. And for the monoprotic strong acids, that is the HCl, HBr, just one hydrogen, the concentration of the hydronium or hydrogen ion is the same as the concentration of the acid. So the problems that you do with pH of strong acids are dead simple. If a problem says it is 0.040 molar in HClO4, then that means you have 0.040 molar of hydrogen or hydronium ions, and you simply take the negative log of that value. Very straightforward. And again, I guess because that pH, the concentration had 2 significant figures, then the pH should have 2 decimal places, 1.40. Now, if you are looking at a strong base, these are the soluble hydroxides, and that would be the alkali metals, the lighter ones, and then the heavier alkaline earth metal hydroxides. So we have the sodiums, the potassiums, the chlorides, or with hydroxide, and you could have calcium or strontium or barium hydroxides. Again, these totally dissociate, but now that you can see, since we have 2+ charges, you won't have the simple 1-to-1 ratio sometimes, and you have to do slightly bit more math. But other than that, it's very simple, and it's also a good way to demonstrate that there are actually 2 ways to solving pH problems now. So in this particular problem, if we have a solution that's 0.028 molar in NaOH, since it's 1 sodium and 1 hydroxide, that just means that it's 0.028 molar in hydroxide. Now method 1 is a little bit more cumbersome. It's the ion product constant for water over the hydroxide. That will give you the hydrogen. Then you take the negative log of the hydrogen ion concentration and you'll have pH. I personally like the second method better. This time just take the POH. So if it's 0.028 molar, then take the negative log of 0.028. If that's the POH, that handy dandy equation is 14 minus the POH will give you the pH. Remember, the sum of the pH plus the POH always equals 14. I like that way better myself. When you get to problem B, this time notice that if you have a 0.0011 molar solution of calcium hydroxide, yes, it's 0.0011 molar in calcium, but we only care about the hydroxides. And since you have a little 2 there, you have to double the concentration. Now we have the hydroxide ion concentration. I again would like the second method better, but let's take a look at the first. Take the ion product constant for water, divide it by the hydroxide ion, you'll get the hydrogen ion concentration, of which you can take the negative log, from which you can find the pH. My preference, though, is take the negative log of hydroxide and subtract that number from 14 to get pH. And that's pretty much how straightforward pHs of strong acid and base problems are. So, as you hopefully can conclude, it's going to be these guys in the next section, 16.6, acids, that are going to be the more complex type of problems that we will spend more time on. Once again, please refer to your teacher instruction sheet to find out which problems will directly relate to problems of pH involving strong acids and bases.